Good evening, students. Today we are going to see a sample problem in ladder friction. So the given problem is a uniform ladder of weight 100 kg and of length 4 meter rests on a horizontal ground and leans against a smooth vertical wall. The ladder makes an angle of 60 degree with horizontal. When a man of 75 kg stands on the ladder at a distance of 3 meter from the top of the ladder is at the point of sliding. Determine the coefficient of friction between the ladder and the floor. So in this question, if we read, so we will come to know two important points. The first one is the point of sliding is occur when a man of 75 kg weight stands on the ladder at a distance of 3 meters from the top of the ladder. It's given in the figure also. And one more important point is given as it's a smooth vertical wall. So obviously we won't have any friction at that particular point. That is at point B, the frictional force will be equal to 0. Anyway, in detail we will see. We will draw the free body diagram of the ladder AB. So the AB ladder is making an angle of 60 degree with horizontal. Then the total length of the ladder is 4 meter. So from the top of the ladder with the distance of 3 meter, the man stands on the ladder. So we know very well that the total weight of the ladder is 100 kg. So here I am multiplying into 10 to convert it into Newton. Otherwise you can multiply it into 9.81 as we discussed in the class. So obviously the weight of the ladder will act exactly at the center of the ladder. So the distance between the weight and the point B or A is equal to 2 meter. So next one is, as we discussed, it's a 75 kg. A man stands at a point 3 meter from the top of the ladder. Here also, I am multiplying into 10. So 75 kg will become 750 Newton. You can multiply it with 10 or you can multiply it with 9.81 to convert kg to Newton as we discussed in the class. But clearly mention that which one you are multiplying. According to the condition, so when the man stands at 3 meters from the top of the ladder, then the ladder starts sliding. So that is the given condition. So the motion is towards down. So obviously as we discussed earlier, the frictional force at point B will be up. So that value is FB. So we know very well that the friction will act quite opposite to the movement of the ladder. But in this problem, they have clearly given that the vertical wall is smooth. So this force will become 0 because it is a smooth wall. So the smooth wall will not create any frictional force. So apart from that, at that particular point, we will have a normal reaction, that is NB. This is due to the wall and the point of contact. So normal reaction will be perpendicular to the wall. The next one is, we are coming to the point at A because the point A is in contact with the ground. So when the ladder is sliding towards down at point A, the ladder will start sliding towards left. So because the ladder is moving towards left, the frictional force will be towards right. So it is FA. And apart from that, at point A, the ladder is in contact with the ground, so it will have a normal reaction. So this is the free body diagram of the ladder. So next one, now we know the free body diagram. We are going to solve and we are going to find out the coefficient of friction between the ladder and the floor. So we will solve one by one. So first one, to solve this, as we have seen in the earlier class, we have to substitute the equilibrium equations. We are going to substitute the first equilibrium equation, that is summation of forces with respect to horizontal or x direction or x axis is equal to 0. So here we are assuming that force acting towards right is positive. From the free body diagram, we can see that is frictional force at A is acting towards right, and then the normal reaction at point B is acting towards left. So in this condition, so FA is acting towards right, so it is positive. NB is acting towards left, it is negative. So we can substitute FA minus NB is equal to 0. So we can substitute NB is equal to FA, and then we can rewrite FA as mu multiplied with normal reaction. So mu is the coefficient of friction and Na is nothing but normal reaction at point A. So we don't have any value, that is we don't have Na also and we don't have Nb also, so we cannot calculate. So we are unable to calculate mu A. So there is the asked in the problem. So determine the coefficient of friction between the ladder and the friction. So the coefficient of friction between the floor and the ladder is given as mu A. So now we are moving to the next equilibrium equation. So this is a free body diagram again. And the equilibrium equation, we are going to solve the second one, that is summation of forces along vertical or y direction is equal to 0. So here we are assuming that force acting towards up is positive. So here we will see one by one in the free body diagram what are the forces are acting upwards or vertical. So the first one, normal reaction at A is acting towards up, and then 1000 Newton, that is the weight of the ladder, is acting towards down, and then 750 Newton, that is the weight of the man, is acting towards down. So anyway, we have already seen that FB won't come because it's a smooth wall. So now Na will be positive and 1000 Newton will be negative and 750 Newton will be in negative as per our assumption. So we can substitute Na minus 1000 minus 750 is equal to 0. So from this we can calculate Na is equal to 1750 Newton. So this value, that is normal reaction at A value, we can substitute in the equation 1. So if you are substituting in equation 1, so we will get NB is equal to mu A into Na, that is equal to 1750 mu A. So as I said, mu A is the coefficient of friction between the ladder and the floor. So here also we are unable to calculate the value of NB and mu A. So we are going to the next equilibrium equation. So again I have a diagram. Then I'm going to the third equilibrium equation, that is summation of moment at any one point is equal to 0. So here we are taking with respect to A. So summation of moment about A is equal to 0. And you know very well that we will assume that clockwise moment is positive. So in this free body diagram, with respect to A, I am going to give you what are the forces are going to create a moment. So the first one is Na, which is acting perpendicular with respect to A, but it is acting at point A itself, so it won't create any moment because the perpendicular distance with respect to the point A to the normal reaction A is equal to 0. Next one, we are having 1000 Newton force. So we have to calculate the perpendicular distance with respect to A, and then we are having 750 Newton. For that also we have to calculate the perpendicular distance with respect to A to calculate the moment. So 750 Newton and 1000 Newton are acting towards down. So with respect to A, it will create a clockwise moment. Next one we are having, that is NB, normal reaction with respect to B. So it is acting towards left, so we have to calculate the perpendicular distance with respect to A. So based on the direction, the normal reaction will make the ladder to rotate in counterclockwise or anti-clockwise, so that moment will be in negative as per our assumption. So now we will see one by one. So for better understanding, I have taken the ladder and the forces which are creating moment with respect to A separately. So now we will see one by one. So we are having normal reaction Na and 750 Newton and 1000 Newton and normal reaction B. So as we discussed, normal reaction at A will not create any moment because the perpendicular distance with respect to A is equal to 0. So We will calculate one by one. The first one is Na multiplied into 0. So as we discussed, so normal reaction A will not have any perpendicular distance with respect to A, so it is 0. So only here I multiplied normal reaction with 0. So this is Na. Next one, we are moving to the 750 Newton. So the 750 Newton, I have to calculate the horizontal distance because the force is acting perpendicular. So the horizontal distance with respect to A to that force 750 Newton, if we calculate, then we can find out the moment. So this distance is the perpendicular distance with respect to A for the force 750 Newton. So we know very well that the diagonal value of the ladder up to that point is 1 meter because from B he is standing 3 meters. So with respect to point A, it will be 1 meter. So we know the formula that 1 meter multiplied into cos 60 will give the perpendicular distance of 750 Newton. So that's only we have substituted 750 multiplied into 1 into cos 60. For better understanding, I have put 1. Next one, we are moving to the next force, that is 1000 Newton. So with respect to A, I have to calculate the perpendicular distance of this 1000 Newton. So this is the distance. So we know very well that the 1000 Newton is acting at the midpoint of the ladder, 1000 Newton with respect to point A, then this distance will be 2 meter multiplied with the cos 60. So 2 meter multiplied into cos 60. So I have written 1000 multiplied with 2 into cos 60. So next one, we are having the force normal reaction at B. So it is going to rotate the ladder in counterclockwise. So I have taken as minus or negative. So now I have to calculate the perpendicular distance of this. So I knew very well that 4 meter is the total length of the ladder. So 4 meter into cos 60 will give the horizontal distance, but I want the vertical distance. So 4 meter multiplied with sine 60 will give the perpendicular distance of the normal reaction B with respect to the point A. So please draw slowly, then you can understand which one is the horizontal distance and which one is the vertical distance, and with respect to A you will come to know which one is the perpendicular distance for the forces 750 Newton, 1000 Newton and normal reaction at B. So slowly you calculate, you won't make any mistakes. So once we substituted that Na multiplied into 0 plus 750 multiplied into 1 into cos 60 plus 1000 multiplied into 2 into cos 60 and minus NB, that is normal reaction at B, multiplied into 4 into sine 60 is equal to 0. From this equation we can easily calculate NB. So I have got NB is equal to 396.9 Newton. Please check it out. So those who have substituted 9.81, your value will be somewhat less. So please clearly mention that whether you are multiplying with 10 or 9.81. Okay, once we calculated the normal reaction at point B, we can substitute this value in equation 2. We will get NB is equal to 1750 mu A. So mu A is equal to NB by 1750. So from this, if you are substituting NB is equal to 396.9 Newton divided by 1750 in the equation of mu A. So we will get the answer mu A as 0.226. So this is a simple problem in the ladder friction. So I am going to give you one more problem in the similar way. So try to solve it and then post your answers in the comment box. So here a uniform ladder of weight 1200 Newton and of length 7 meter rests on a horizontal ground and leans against a smooth vertical wall. So here also the condition is smooth vertical wall. The ladder makes an angle of 50 degree with horizontal. So it's given in the diagram. When a man of 60 kg, here the one value is weight is given in Newton, another one is in kg, stands on the ladder at a distance of 4.5 meter from the top of the ladder is at the point of sliding. It's similar to the earlier problem, only the numerical values are changed. So determine the coefficient of friction between the ladder and the floor. So please calculate and post your answers in the comment box. So important thing, again I will repeat. So the point of sliding is important. So it is impending motion. You can use the equilibrium equation. The second one is it's a smooth vertical wall. So the frictional resistance at point B will be equal to 0. You will have only normal reaction at point B. Have a nice day. All the best. Thank you.